company Clarified Security, and it has been 14 years now. And I'm doing their web application pen tests, also developing and lecturing web application security course, and additionally I'm a co-lead in the OWASP flagship project called Application Security Verification Standard. So I use experience from those roles to explain a bit widespread and frequently seen and also underestimated problems what may happen on the application layer and may cause denial of service attacks. So first I explain some parts of the title. First, sniff off. I'm not going to give you full detailed coverage of the topic. It is just sniff of the topic. If I say application, then in practice I mean web application. By denial of service, we mean that the application or the service is not usable. It may mean that entire service is completely down for everyone, or it is not usable just for a single person. And often denial of service is described as like mass flood network level attack, which means that people think, okay, I put web application firewall in front of it and I'm done. Attacks in this presentation does not require any vulnerabilities on the server side, like syntax problems, like SQL injection, command injection, remote code execution, and so on. And also I don't cover any mass flood attacks on the network level. I'm going to describe situations that are caused purely the lack of threat modeling and analysis. And this results in missing input validations, limitations, and wrong architectural choices. In short, if application is built in naive thinking that all the users are good and without any bad intentions. So I like to call it a hope management. So as a co-lead of the OWASP ASVS project, I just need to point out there are requirements, precise requirements to address those requirements, that you need to have documentation to define that which kind of services are time-consuming and resource-demanding in your application, and you need to have implementation to avoid loss of availability in case those services are misused. Also, there are requirements to address business logic and anti-automation with the same pattern. First, you need to have analysis and documentation, which kind of limits you must have. And then also, you need to have them implemented as well. If those requirements were ignored, then you may end up in a denial of service compatible application, which means that it may provide time-consuming responses, which means slow responses from the application. And it also puts to the spotlight one extra term, connection pool, which means maximum parallel connections from one service component to another. And we need to watch each connection separately, like from the front end to the backend API, from backend API to database, from backend API to some external API, and so on. And from the attacker's point of view, weakest link wins. Resource demanding means that it requires a lot of some kind of resources to process some request from the user. For example, requires a lot of memory or CPU to calculate something. So if attacker is able to misuse the slow response to occupy entire connection pool or required resources, it causes a loss of availability. In other words, it is a denial of service attack. If this situation happens, attacker doesn't need to search any new vulnerabilities, just hammer those weak API endpoints with 500 parallel requests and the job is done. You may think that, okay, I banned the IP and I'm all good, but stay tuned. So let's say the application does not provide any time-consuming or problematic APIs. And evil thinking in this situation should be, from the attacker point of view, as an attacker, can I make any functionality to be time-consuming and resource-demanding? So we are going to look to the limits. Every kind of validation, like maximum file size, numeric values, max text lengths, and every kind of amount of child objects. And the question from the attacker is, what if there is no limit? One of my favorite files are zip files. You may think that, come on, who is using zip files? But think again. Many Office files are zip files, like Excel files, docx files, LibreOffice files, and all Estonian Digidoc containers are also zip files. Now, zip-bomb is an archive file that has huge uncompressed file size, at least compared to the archive file itself. Give an example here shows an Excel file, which is 50 megabytes, and I turned it to the zip-bomb file, which means that its unpacked size or uncompressed size is 50 gigabytes. So if the server starts opening it, it will not handle it well. And important here is to point out that it is problematic to the application layer only if the server starts reading the file. So why server should read it? For example, when it imports the data from the Excel file or converts docx to PDF. And also, if web application firewalls or antiviruses try to check inside the file, is there something malicious, they may just crash. If the application allows end users to download and open such files, the end user device may just crash as well. But this is not the application layer problem anymore, although it could be avoided on the application layer. But anyway, take it as just an example. Just if you process the file on the server side, and every kind of files have their own features, what can go wrong there? One frequently reported problem during pen test, on the web page, user can choose how many items they can see in the list per page. And often the choice is given as drop-down, like choose from 25, 50, 100, and so on. And on the server side, there is no validation that the chosen value was in that list. So if there is no limit or no reasonable limit, the attacker can just ask from the application, hey, return me all the rows. And if there are enough rows, then most likely the application just is not able to build the output. It runs out of time or out of memory. One may ask that how do you manipulate it? Well, use browser developer tools or use proxy or making request from a command line. Next simple and widespread problem is validating the text length. And if the validation is missing from the application layer, usually the length limit applies from the database field type used to store that value. For example, if the value to store is expected to be longer than 255 characters, then quite often database field type text is used, and it allows to store 65 kilobytes. But if someone thought that it's awesome idea to use medium text instead, it means the length 16 megabytes, and if someone used long text because it felt long, then it actually means 4 gigabytes, and you have problems immediately. Imagine some users start downloading in API response 4 gigabytes of data, especially when the client is a mobile device. But from the application layer denial of service perspective, we are only interested, can the application even build the response, or it runs out of time or runs out of memory. If the application has some issue, which first may seem like not important, not a big thing, the question is it possible to amplify it or is it possible to multiply it? Let's take again the missing max length for the text field. The text field alone is 65 kilobytes, not a big problem. But now the question is how many times I can get this to the output. Again, we go back to the list fields or to the list. How many times it appears to the list? Can I manipulate how many rows are returned? Also, often it's possible to create some child objects, let's say comments to some document. And if the functionality is not expecting too many rows, then often the functionality is not paginating them. which means it shows entire list to the output. So you don't have, again, any limit. So let's do some math here. If I have only one text field to play, like 65 kilobytes, but I have 100 rows, then it's already 6.3 megabytes. It already causes some delay and problems for the client to render it. But if I don't have limit how many rows I can create, and I have 3 fields to play, it's already 190 megabytes of noise. And we can keep multiplying. Well, we can keep multiplying till we find the limit for the application. So far, we have talked about one single request. It may cause some slow response, it may crash, but it doesn't seem like too bad. One simple thread. And for that reason, the problem is also underestimated. So attacker may need way more requests to actually cause denial of service attack. And I can see immediately happy and confident faces, but I have firewall. So what kind of defense is provided by firewall? It's always up to configuration per instance, but in most cases, out of the box, web application firewall is to stop stupid package flood and also attack requests with known patterns. And if it does all that, it does the job well. But if we are going to play with the business logical limits, by default firewall rules are not enough. It must be configured really detailed per request, per API endpoint to provide actual defense. And most likely, the firewall configuration is not the best place to do that. So how many requests do we actually need to cause denial of service by occupying the entire connection pool if the application provides slow response? If there's no limitation, then attacker can send all the requests at once, and we don't need to do any math here. But if there is a limit, then attacker just need to fill the connection pool with the time or request available. For example, if the connection pool is 100 connections and the timeout is 60 seconds, then basically you have 60 seconds to fill 100 connections. But keep in mind, this was only by traffic from a single client, from single attacker. But there are other users on the web server. Attacker can use multiple IPs. So let's say attacker can use 5 IP addresses, then it's enough base to use just one request after every 3 seconds. What your firewall thinks about that? So most likely, the firewall will not catch it. And if the timeout is longer, then we just can multiply numbers by, for example, 5. Now, if the denial of service attack was successful, application was taken down, then most likely some analysis is happening and IP addresses, or attacker's IP addresses will be figured out and will be blocked. An attacker can come with new IP addresses or also can use IP block against the application. One option for attacker is to force other users' browsers to make those HTTP requests. Previously, we manipulated the list view and asked million rows to the output, and the attacker can generate or create an HTML content with image tags, and the image tags is going to point to that vulnerable API endpoint. So if the targeted application functionality provides rich text editor, for example, when you can apply images, then the goal is already achieved. Or the attacker can also create the HTML content and put it to any own controlled, which means hacked website. So if the visitor's browser loads the HTML from the application or from the external site, it starts making HTTP requests to the vulnerable API endpoint as loading images. In this case, 1,000 images at once, but we are not limited to that. This is just an example. Now, important is to understand that each visitor is going to make those HTTP requests from their own browser, from their own IP. what exactly you're going to block. And if you do block them, because they're making too many requests, you are causing denial of service for those users yourself, because they cannot use the service anymore because their IP is blocked. And blocking one user IP may mean blocking entire office, because external IP can be just one IP for entire office. So to conclude all that, every missing limit can be amplified. Now, as you collected many evil ideas here, just a reminder that for testing a system security, you need to have permission. That if you start taking things down because you see the presentation, I'm not guilty. And for everyone on the defending side, good luck.
Yes. I think we need to emphasize that this is all for educational purposes only, and RIA in no way condones doing all those things, and whatever the legal departments. Okay, anyways. So, great talk. Are there any questions from the audience? Let's go right here again.
Yeah, thanks. Great talk. Working in a development house of web applications, I have noticed that the same problems are often surfacing with regular users. It doesn't have to be malicious user. And I have seen found the similar things during things we have been calling load tests or stress tests of the systems. Have you seen any connection on this side of your teaching and pen testing side with also selling it guys, it's not just for security, it is for your sales funnel to first work fast, and we can help with our security things, fix also problems of the other departments, is there a cross linkage of that?
So if the application cannot handle good users when they just come together, then I call it again this denial of service compatible application. So then we don't need to manipulate anything. Yeah. So the load or the stress test or load test must be done, and then we can reach to those problems. Otherwise, we don't need to use our brain to think clever solutions. We just can visit it, and it's already down. Yeah.
All right, thank you very much. Let's continue. Another round of applause, please. Thank you.